for it to switch like. It's like really small.
My jaw's not aligned right, so I'm gonna have to do that with my butt and then
I don't know if it's gonna
she's not going
be
now.
in the front or if
You're
it's
not
gonna be like everywhere.
You're not going.
Teeth are so weird. I just can't get over it.
I just decided not to get braces.
$5.
I'm maybe getting them soon.
I was supposed to, but I was like, yeah, I really don't think I need it. So I did not understand 22 to 28. I did it, or 21.
Oh yeah, we did some.
I got the first two and then I was like, this makes no sense.
I didn't explain it to you.
I don't know.
Yeah, because I didn't understand it at all.
I did it wrong.
You said 27? I got like RT equals 8 or something.
Sure. How'd you figure that out?
I have no idea.
So, this,
So I figured out how to do it, but I
so the
think
perimeter of that as well. So if you go.
Because I think what you do is like,
So when you add all those together.
if it's 18 over 12, you have to
So
go
that gets your perimeter.
4 over x,
Yeah, like,
6
wait,
over y, 8 over
Your
z.
perimeter.
You
Yeah.
guys switch that.
Fraction. Should be
On
18
some
over
level.
12.
But I don't know
I
which
got
one.
And reduce these
8 over
down
3.
to,
10 over 3 and 4.
yeah,
3, 2,
and then
3 over 2.
Yeah,
Or-
3 over 2. 20, you got 20 over 3, 35 over 3 and 5.
Okay, we'll start with y,
We got
do 6 over y
y
equals 3 over
Yes,
2.
36 over 5 for x.
And then,
No, wait, 6 over 5.
I guess I did that.
so that's like 24 over
Okay.
7.
27 to 28.
And then 40 over
Do you
3.
show your work on another paper, Erin?
Yep, 3y.
Actually, yes.
You do? Okay, I was just wondering.
8 over 3.
No,
Yeah.
4.
He does it in his head.
And then 8 over 3 equals 8 over 3 and 4 again. I put the answer on this.
I got 6
I'd be like,
Wrong.
My dad-
Because you have to flip it.
Good for you.
It's slightly different.
How'd
It's
you
not
know number?
exactly the same.
27.
Well,
Don't write it down just because I said it.
Just she guessed. I would, that would be my favorite. Okay.
Alright, what questions do you
It's
have?
the same as the other one.
28.
One for 25.
27 and 28.
27.
Are there any questions on 19 through 24?
Yes. Oh, 25, 135. 21 or 23 or 24, you could fix it. And then 15.
Or 22 is
I
fine
got
too.
9. I think it's wrong.
Well, put a star next
What
to
is
it.
it?
Question mark. I just, it just
And
didn't
then I
make
got
sense
five.
to me.
Oh, I got
at all.
28.
Like I messed up, like understood it, and then I got totally different answers from everyone else, and then it didn't make
But
sense.
you can do it different ways.
Yeah, well, it
So,
didn't.
Alright,
Yeah.
21.
If you flip it.
no, like if you do like 18 over 12, and if you switch it, you'll get it different ways. Yeah. There's multiple ways of doing it. Of course. You don't have to have it. I have no idea what you got.
Yesterday, she came in with Spanish bragging about how she worked for your brow.
Oh yeah, that was so retarded. She like pulled it out and like put it in.
Okay,
I remember
so you have to find the one pair, at least one pair of corresponding sides. So in this case, that would be what? Yeah.
IJ and EF.
Yes. So the 6 and the 5. So you just write that as a ratio, 6/5, 4, 5, 6, but you need to keep it consistent throughout. And then we can use that to find the others. So if we're going to find x, x is in the same quadrilateral as the 6, so that will go on the top. And x is corresponding to what?
6.
6, right? And then you would solve that proportion. Then you'd have 6/5 equals, and to find y, y is on the same quadrilateral as the 5, so the y has to go on the bottom, and the 8 will have to go on the top. And then to find z, it would be, let's see, 3 over z. So you should get here 5x equals 36, so 36 fifths for x. Here 6y equals 40, so 46 or 20/3. And here 6z equals 15, so that would be 5 halves. Yeah. For number 21. Maybe everyone should be checking. Did you keep your proportions consistent? Yes, with the matching side going across from the right quadrilateral part, Mac?
I was just gonna ask if we could do either like 27 or 28.
Okay, we're still looking at the first half of that, but then yes. So, Nina, I don't know if that's helpful.
Yeah.
Yes?
Yeah.
For 23, you said 23 and 24 also. 23 and 24, in order to get this original, you have to use the perimeters. Okay. Alright, 27. RM is 3, MS is 4, NT is 5, and RT is okay, so triangle RMN is similar to triangle RST. So if we look at triangle RMN and then triangle RST, we have to find the ratio of the sides. So RM is corresponding to what side of triangle RST? Back? Right, RS. So the ratio of RM to RS would be what? 3 to 7. Right. So to figure out this whole side, you have to add 3 plus 4. So that gives you 7. So the ratio is 3 to 7. And then that would equal the ratio of RN, which let's call that X, to RT, which would be what as an expression? This will require some algebra, unless you did it a different way, which you may have gotten right. Sarah?
That'd be 5 plus x.
Yes, I was gonna say X plus 5, but yeah, same thing. Okay, and then you can solve that as a proportion. So that will give you 3 times x plus 5 equals 7x. So 3x plus 15 equals 7x minus 3x here. So 15 equals 4x. Okay, so x equals 15 fourths. Of course, they couldn't give us a nice number to work with. And so then to find RT, you'd have to add 15/4 plus 5, so 15/4 plus 20/4, so 35/4. That one was a little complicated, wasn't it? Okay? Yes? Questions? Morgan?
I'm not on the test because I didn't memorize everything that you just
Memorize?
Yeah, like I don't like, I
Well,
understand
hopefully
what
you
happened,
shouldn't
but-
have to memorize it, so that means to me that you don't quite understand where I'm coming up with it. Right?
Like, I feel like I understand what you just did, but I don't think I could do it again on my own.
Okay. Which part? Like the algebra part, or like the coming up with this part?
Yeah, I'm coming up with it.
After that, you're fine
Uh-huh.
with the rest?
Yeah.
Okay. So, to come up with this, it might be helpful to separate out the two triangles, to draw them separately. So if you draw triangle RMN, I don't know what's going to be on the test yet or not, but I do want you to understand and not feel like you have to memorize the steps, you know. And then triangle RST, it might be helpful to draw them separately. And so then you can see really easily that that's 3 and RS is 7. And then you know you're going to have to come up with like something to go on these two parts, right? And we don't know what we really don't know what either one of them is. So that's why we have to just pick something to represent. So just like they have letters representing the sides that you don't know on those, you just pick a letter to represent it, Madeline?
Like after you're done doing this, can you do 28? Cause I understand this one, cause like it separates into two triangles, but 28 like.
28 should as well, because they're still similar triangles.
Yeah, it just confuses me.
Okay. Yes. And so then, since we do know this measurement here, that's how we came up with the RT, because we said that this part would be x. So that would be x plus 5 as an expression. And then after, if you draw that out and you can figure out those two parts, then I'm guessing the proportion part would be pretty okay, since you've been able to do that on the rest. But it's just coming up with these two sides probably that was the challenging part, right? Yes?
I think so. It makes sense now.
Yes?
Thank you.
Okay, good. I'm glad you got. Alright, 28. RM is 3. That's the same. MS is 4, that's the same. And MN is 4. Find ST. Okay, so if you have two separate triangles again, over here. So you have, this is 3, this is 4, what's RS? 7, and you're finding XT. That one's actually easier than the last one. So it would be 3/7 equals 4 over x.
Okay. I guess that's just.
That's okay. Does that, you see it now? Yes?
Uh-huh.
Alright. Anything else on that? Section, any other questions? No? Okay. There's actually only one more section we're going to do in this chapter. And so I'm planning on a test on Wednesday, possibly Thursday, depending on how this goes. We are going to be doing proofs. And since we're almost to the end of class, it probably will be more like Thursday. And practice is no story of the time. So, anyways, this is going to be the last section, and we will be testing on chapter 6 soon. Alright, proving triangles similar. So we spent a lot of time proving that triangles were congruent, right? And proving triangles similar is going to be similar, for lack of a better word. Postulate 17 is also called, I didn't put that on here, the angle-angle postulate. So similar to how we had that for congruent triangles. And that says that if two angles of one triangle are congruent to two angles of another triangle, the triangles are similar. So if, for example, angle A is congruent to angle B, and angle B is congruent to angle E, then triangle ABC is similar to triangle BE. When you only have three sides, so when you have a triangle, there's only one way to set up the sides so that the three angles could be congruent. So that when you do that, it automatically makes the sides proportional. So basically in a triangle, if we know all three angles are congruent, then we know that it's proportional. And so we really only need to know two angles, because if two angles of one triangle are congruent to two angles of the other, we can prove that the other angle would be congruent because they both will add up to 180 degrees. I think we even have a theorem that says that specifically. And then the other theorem, which doesn't have a nickname, is that if an angle of one triangle is congruent to an angle of another triangle, and the lengths of the sides, including those angles, are proportional, then the triangles are similar. And perhaps we don't have a name because that would be also side angle side, and we already have one that says that. But in this case, it's not that the sides are congruent, it's that the sides are proportional. this one's saying if angle A is congruent to angle D and let's say AB over BE equals AC over then triangle ABC similar to triangle DEF. So the proportional sides do have to be the two sides that are enclosing the angle. So the length of the sides including those angles means we have to be talking about the sides that are making up the angle. We can't talk about BC and EF being proportional to AC and DF, because those are not the sides that are including the angle. Okay? Alright. Let's look at the oral exercises on page 207. We're going to classify each statement as true or false. For the first 8, looking at the similar triangles A, B, C, and R, S, on page 207. So number 1 says angle A is congruent to angle R. True, they're similar, and those are corresponding angles. Goodness. If the measure of angle R equals 70, then the measure of angle A equals 70. True. If AB equals 5, then RS must equal 5.
False. Wait.
They're similar. Do the sides have to be congruent? No, that would be false. They just have to be, they would be proportional. Number 4, AC over RT equals TS over CB. False. Why is that false? Sarah?
Because it has, from one triangle, has to be like AC is on the top, but then TS is on the bottom, so it can't.
Right, they need to switch, if that were to be true, they need to switch the CB to move it to be on the top so that those would be matching up. Good. Number 5, if AB over RS equals 3 over 5, then AC over RT equals 3 over 5.
True.
True, that would mean that they are proportional. Good. 6, the ratio of the measure of angle C to the measure of angle T is 1 to 1.
True.
True, because the angles are congruent. 7, if the triangle ABC is a right triangle, then triangle RST is a right triangle.
True.
True, because the angles again have to be the same. So if one has a right angle, the other one will also. 8, if the measure of angle B is 30 and the measure of angle C is 80, then the measure of angle R is 60.
True. True.
False.
False, what would R have to be? It would have to be 70, right? Alright, these are not relating to the picture. 9, all isosceles triangles are similar. False, that's correct. 10, all equilateral triangles are similar.
True.
That would be true. 11, all isosceles right triangles are similar.
True.
That is true. On page 206, if you look, there are 2 red statements in your book that are not theorems or postulates, so we can't use them in proofs, but they are true. You could prove them to be true. One of them says, if an acute angle of one right triangle is congruent to an acute angle of another right triangle, the triangles are similar. That would mean, like, to prove that, we could say, you know, all right angles are congruent. And so if they both have a right angle and one other angle, then we could use the AA postulate. The other one says if 2 isosceles triangles have congruent vertex angles, the triangles are similar. And that would be because they would have 2 angles ultimately that would be similar, because the vertex angles and then the other 2 angles have to be congruent. So if the vertex angles are congruent, then the other 2 angles would have to be also, because the other 2 angles are congruent to each other. If that makes sense. Alright. Let me see. Why don't you just do 1 through 10? So, page 207 and 208, numbers 1 through 10. And then we'll definitely spend Monday on this again, possibly Tuesday, and then we will review everything from chapter 6. Morgan?
Can you explain like what it means to be proportional?
That is like what we were doing in the last section, where you could set up a 2 ratios and they would be the same. So like we did here, if you set up a ratio with the corresponding parts, they would be equal to the ratio of the other corresponding parts.
So if it makes a ratio, it's proportional?
If the ratios are equal of the sides. If the ratios of the corresponding sides are equal, then it's proportional. So like if you have, oops, 4 and 8 and 3 and 6, I know 4, 8 divided by 8 would make 1/2, and 3 divided by 6 would make 1/2, so they would be proportional.
Okay. So it could be like anything as high as like 100 over 13 or something?
Yes, as long as it would be the same for both.
Okay, that makes sense. Thank you. Do we have Imaginarium today?
I don't think so, because I think it was supposed to be on Wednesday. I really don't know, honestly.
This is Faulkner.
Yes.
For number 3, they only have